Hi everyone, welcome back to our channel. Today, we are going to learn about heat treatment chapter, but our group will specifically discuss about cold point location and thermal destruction of microorganisms. We hope to have your attention until the end of this video. Without any delay, let's get started. The definition of cold point location is it is the zone of the lowest heating location of a container where the product temperature at the location increases more slowly than the heating median temperature. It is measured by placing a thermocouple at the cold point location to record temperatures in food during processing. In cylindrical containers, the cold point location is at the geometric center for conductive heating and approximately 1/3 up from the base of the container for convection heating. These are the examples of thermocouple.
Importance of cold point. Thermal resistant pathogens or microorganisms are responsible for product spoilage may be located at the lowest heating location in container. This location must receive a thermal process equivalent to the established time or temperature relationship for eliminating the microorganism. It is important for a heat processing to cause enzyme and microbial destruction but at the same time retains the nutrient and sensory qualities of the product. Higher temperature and shorter processing time can better retain product nutritional and sensory properties. The time required to heat the coldest portion of the container of food up to the sterilizing temperature depends on container size, container shape, type of product, particle size, and type of container.
The heat resistance of microorganisms usually expressed in terms of thermal death time (TDT). It can be defined as time required at a specific temperature for complete destruction of the organisms or spores and time required to achieve a specified reduction in microbial numbers at a given temperature. D value. It is the decimal reduction time needed to kill specific microbe at a specified temperature. It is also the time needed to destroy 90% of the microorganisms by one log cycle. D value is used to determine the heat resistance or heat sensitivity of microbes and to predict the number of microbes surviving for different lengths of thermal processing at one temperature. Larger D value at a given temperature resulting in higher thermal resistance of that microbial population. In modern food production, canned foods are subjected to heating process that will reduce the probability of the survival by Clostridium botulinum spores by 12 log cycles. In other words, the probability is that 1 out of 10 to the power of 12 cans would have one spore of Clostridium botulinum surviving.
Next, Z value. It is the temperature that is required for the thermal destruction curve to bring about 10-fold change of the D values or to move one log cycle. It is also based on the destruction of microorganisms that is dependent on temperature. The higher the temperature, the more rapidly microorganisms are killed. Heat treatments with small Z values are highly temperature dependent, whereas those with large Z values require larger changes in temperature to reduce the time. Lastly, F value. The definition of F value is the time required to destroy a given percentage of microorganisms at a specified reference temperature and Z value. The value commonly used in the canning industry is the F value, which is based on 12D. The decimal reduction for Clostridium botulinum. The reference temperature is 121.1 degrees Celsius. For instance, to achieve 12D, a can needed to be heated at 121 degrees Celsius for 2 minutes and 4 seconds. Thus, the value of F is 2 minutes and 4 seconds, and any sterilization of less than that minute is considered inadequate. That is all from us for now. Thank you very much for staying till the end. See you when I see you!